Okay, we have here today this kind of crazy long integral from the UNSW Integration Bee. This was 2020 problem 10. We have the integral of secant squared x, secant squared tan x, secant squared tan of tan x dx. Okay, the first thing I notice here is whenever we have trig functions embedded within other trig functions, that's going to usually be a problem unless we can do a u substitution. And then looking around for a u substitution, well, we have everything secant and tangent, which works well together. And actually, what you can do is go from the inside out, like go to the furthest embedded function. We have a tan x here. But the fortunate thing about that is if we made a u substitution for tan x, the derivative of tangent is secant squared x. Well, we have that, we combine that with dx, and we have the derivative right there. So we could just go right ahead and make this our u substitution, and that would help us simplify this. But then before I do that, the thing to notice is even after we make that u substitution, here we're embedded twice. So when we do the substitution, we'd have secant squared tan of u. So we'd still have a problem here. Well, it turns out in problems like this, we could do the first substitution, then we could do another substitution. But we also could try to save a step and kind of consolidate and just try to do one substitution. If we make the substitution for this whole thing inside the secant here. So what if I call this my u? So let's just go ahead with that. So I'm going to say my u is going to be tangent of tan of x. And then we just need to take a derivative of this thing. So du, derivative of this, you just have to be a little careful. Derivative is going to be secant squared here, tan x. But we're going to need the chain rule. And so we take the derivative of tangent, and then we multiply this by secant squared x dx. But this works out pretty nice because we actually can have everything here plus the dx. This is actually the same thing as our du right here, just in a different order. So let's just go ahead with this. So when I make this substitution, now we have this secant squared here and just a u, and then everything else is going to be du. But this here is a really common integral. This is actually going to be just tan of u, and so all we need to do is just back substitute in order to finish it off. So we have, here's our u. So for the solution of this, we're just going to have tan of tan of tan of x. Need the right number of parentheses and a plus c, and that's it. Okay, these are always kind of fun. They like to include one of these in a lot of the integration bees. And as you can see, it simplifies really quick, not too bad. So that's it. Thanks everyone for watching. Have a good day.